All right. So, how has everyone made it through your weekend? Looks like. It looks like you froze again. I don't know why. Like it was like the screen just stuck on him. Okay. So any comments, questions on the video? Anything happening? I know there was like some issues with the video sizing. I was like, it just happened when I edited the video. It like went to the wrong size, so like half the video was all zoomed in and you couldn't see half of it. So I fixed that Saturday, I think. What was it? Is this one? This is one with the perimeter and area and all that stuff, huh? Is that what this one had? Here he comes again. Was it 2.3? Is that what this was?
Yeah, it's 2.3, and it's solving for a variable and and supplementary and complementary angles.
Okay.
Yeah.
Is it cool if I do it from my phone?
Yeah, that's fine. We can see you. That's fine.
Fuck my stupid computer. I'm sorry, it's just stuff.
Yeah, you're good. So are there any like comments on like I guess how the areas were derived and all that sort of thing? Did y'all follow that at all, or was it confusing? That's what I'm kind of wondering. Like, what was your take on all that sort of stuff? The perimeter.
For Marsec 2.3, right?
Yeah, yeah.
Well, kind of remind me of like this. Of course, it was like geometry. So like, it's kind of like I wasn't really good at geometry, but it's kind of like similar. Kind of brought a little bit of like I gotta say like, some stuff that I do know about geometry, like hypotenuse and all that, the 8 like length times width and all that. Like I do remember. So.
Yeah. Well, I think like there's just like from definitions, right? You should know kind of what perimeter is, right? Perimeter is that one dimension you're walking around the object. How far does it to walk around this object, right?
The distance of the objects on the outside.
Yeah. And so we're walking around the edge. So basically walking around the perimeter, like that's what we literally say what we're walking around the perimeter means we're walking around the object, right?
Yeah.
We use that even like colloquially, right? To talk about walking around our property, we're walking around the perimeter. So we use that language like in everyday life as well. Why is it just like pinned on one person? I don't understand. I'll pop up the gallery view then. That's a little better. Yeah, and hit record. Okay, I'm recording. And so, I know I like went through like probably in great detail. Like I'm not expecting y'all to like regurgitate that out, right? Like I hope you're not like freaking out like he's gonna like make us regurgitate these proofs or something like. But like I'm hoping you're like getting something from that. Like you're not just like watching the video and it's like going in one and out the other, right? I'm hoping like maybe there's something there. Maybe you don't even understand all of it, but like maybe you understand part of like what I was doing, right? And I think it's like, and this is just kind of my approach with teaching, right? I think it's really important for you to see these things for yourself. Like math is a deductive sort of logical sort of process that we go through, right? And did she? Oh, okay. I thought people were disappearing. But it's one of the great things about math is that you can see these things for yourself, right? You like, and it's one of my qualms with the way that math is taught a lot of times is that it's taught from a position of authority, right? It's like, here's this rule, and then like if you ask the student to justify it, they're going to be like, if I ask you to justify it, you're going to be like, why is that a thing? You're going to be like, because my professor told me so. But like that doesn't help you out in life at all. Like this class is going to be like 7-hour course, right? Outside of that, after you get out of this course, like just knowing something because I told you so isn't like going to do you a lot of good out there. You have to be able to reason these things for yourself. And with math, we can sort of do that, like based on stuff that we know, we construct these pieces together to create new knowledge, right? Deductively. And so like, I know I went into great detail when I was doing like perimeter and area, and perimeter of a square, I think, is just like from definition. Area of a square, if you understand what area is, those things go hand in hand, right? If I'm talking about like the 6x4 rectangle, it's gonna have 24 square inches. That means 1 by 1 little inch pieces, right? I got 24 of those that can fit in there. That goes like right into the definition of sort of like what area is, and what an inch square unit is, right? Or what our square units mean. What was the next thing? Triangle. Have y'all seen triangles? How to get like the area of a triangle?
You mean like the Pythagorean theorem? The Pythagorean theorem?
I don't think. I'm not sure about that.
Isn't that we have to like draw a line in the middle of the triangle, like multiply the height with the length?
Yeah, if you do the diagonal, right? If you do a diagonal of a square, that will give you half the triangle area, right? Just like you're splitting that square in half. Like it's kind of like, and I don't mean like, I'm trying to think of how to say it, but it's like one of the most obvious ways. Like if I ask you to split the square in half, you're gonna draw a line down the middle of it, right? That's probably the first thing you're gonna do. And if we do that, if we have a right triangle, so that works for a right triangle. If we don't have a right triangle, we make a right triangle out of it, right? We make 2 right triangles. So I did all this in the video. So there is a sort of approach. And another thing, like I said, like I'm not expecting you to know this stuff overnight, because a lot of this stuff, it took people studying their entire lives, and it took hundreds of years of these separate people studying their entire lives to like come up with these sort of things, right? These things aren't things that like people thought up overnight. They were things that like happened over hundreds and thousands of years, right? In long-term developments. Circumference is just a way to say the perimeter of a circle. So if you understand what perimeter is, you should understand what circumference is.
Basically, circumference is the, I guess you could say like the space outside the circle, and diameter is like the space inside or something like that.
Yeah, and so you can think of pi as actually being the ratio of the circumference to the diameter, right? That's one way sort of that they can actually define pi. And you know, back in like ancient Greece and stuff, they didn't have the best tools, and they were like, I'm pretty sure this is 3. I'm pretty sure it's 3. It's like, no, it's like 3.14, and it keeps going, and it's really complicated. But you know, they were like, I'm pretty sure it's 3. Not quite, but okay. So what else? Area of a circle, that's kind of a weird thing. But you can use the area of a triangle to get the area of a circle. You have to make we have to gloss over maybe some like facts about infinity and methods of exhaustion or something, right? But if you understand you can fit an infinite amount of triangles into a circle, it kind of works. It's kind of weird. But we can take things that we already know, an area of a triangle, and we can take things that we know about a circle, and we can combine those two, and we can get the area of it, right? We're working off of knowledge that we know, and we have defined like our sort of axioms, right? The things that we call like self-evident rules, right? There's a sort of like base that we start on in math. At some point, you just have to assume something, right? Like the next thing we're going into is Descartes, Rene Descartes, and his whole thing. He had an existential crisis, and so he was a philosopher / mathematician, and so he was like, "How do I know I exist?" And so he said, "Was it cogito ergo sum?" I believe is what it is. I think, therefore I am. He's like, I have this doubt, and so therefore, since I have doubt, I exist, right? He's a weirdo. But anyway, I can't see the time if I make this full screen, can I? That's a lot better not in full screen. Okay. I can see who's on here better. And so what I want to do, I spent way too long doing that. I want to go into groups.
Breakout rooms?
Yeah, I'm gonna break up into groups, and I want to do like the homework assignment from 2.3. And so what I want to do is I want to do like 3 problems at a time. There are like 9 problems we got to do. If we do 3 problems at a time, we could take probably around like 20 minutes, maybe 18. I think I'll probably do 20 minutes. Let's see. We've got rooms close automatically. And so I want to do that, and then we will like mix up the groups probably and reassemble. Okay. Set this aside. Automatically. There we go. I actually have to do it. And open all rooms. Hopefully this works. I was gonna say, I think if we just try to avoid each other, then we could probably like disperse ourselves out between the students, huh?
So did you put me as a host?
Oh, I gotta put you as a host. Let me do that. Or co-host.
Co-host, yeah.
No, I can't do it.
Oh,
Uh-oh.
Can you add me back into the group I was in? I was having trouble, like, it was having trouble making me join.
You're on mute.
I gotta make Miss Watson a co-host before I do groups. Where is everybody? Come back in. Taking too long, man. 20, 19, 18, 17, 16, 15. I was gonna say though, if we just try to avoid each other, I think we could probably like get them enough teacher time, independent, one-on-one. Okay. I had to make her a host, and now I think we're going back. Does that work? Four, 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 four. Let's join this one.
It says solve for L. Okay.
What y'all doing?
She's letting me see the problems real quick.
We're doing the written homework from 2.3, right?
Yeah, but where's it? God, where's my thing? Why is it not coming up? Oh, why is it doing it?
You might have to, I don't know.
I think it just shut down the program for no reason. That's what
Oh
it looks
no.
like. Yeah, I gotta reconnect my camera right here. Please come up. Okay. So you should be doing the book problems, right? 165, 167, 169.
Okay. Okay. Do you have those problems, Paige?
Yeah. Hold on.
I don't got nothing. Okay. Said 165. All right. I'm so sorry. Thank you so much. Solve the formula. see. Equals
And bounce to the
pi.
other groups. Make sure they know what they're doing. Let me let y'all get started on your own there.
Okay.
I'll be back.
I cannot see that. Okay, pi.
Are we together in what we're doing here, hopefully? So we should be doing 165, 167, 169, right?
Yeah.
Okay. Do y'all need these problems? Need to copy them or no? Or do y'all got them?
Yeah, we got them.
All right, cool. I'm
Thank
probably
you.
gonna bounce, make sure everyone else knows what we're doing. Are they coming along? Do y'all need help with them? Or
Yeah, I need help.
all right. So what are you solving for in this first one?
For D.
For D? If we want to solve for D, what's happening to D? What's the operation here?
3.14. Multiplication.
Yeah, it's multiplication. So if we want to get D by itself, what do we have to do? What's the operation to get this by itself?
Divide
Divide by.
3. I mean D. Shit, my bad.
At
Yeah, you're saying the right thing.
3.14.
Yeah, the pi, right? Divide by pi.
Oh, so you don't divide by D, just pi?
Just the pi.
Okay.
All right, I'm gonna bounce elsewhere and see if they make sure they're at least started on the right thing. I'll be back though.
So the answer will be C over pi equals D.
Hello. Hello, hello. Or not. Are we working on these problems?
Yes.
So we should be doing 165, 167, 169. Do y'all need these problems? Or do you need to copy them?
No, I have them.
Okay. Do y'all need some help on them or?
Yeah, 165. Like, how to like start it? Like that was kind of. I don't know. I was like confused about. I'm still confused over it.
The first one, is that what you're saying?
Yeah.
Okay, so this says circumference equals pi d. So we want to solve for d, right?
Mhm.
And so what else is there besides d?
The pi sign.
Yeah, the pi, right? And so we want to get pi by itself, or we want to get d by itself. There's a pi there. What's the operation between the pi and the d?
To multiply it.
Yeah, this is multiplied. And so if we're getting rid of something that's being multiplied, we want to do what?
Can you say that again?
If we're getting rid of multiplication, then the operation we're doing is the
Oh, division.
division. So we're dividing by the thing that is in front of d. So we're dividing by
3.14 pi.
yeah, just call it pi. We're dividing by pi, right? We divide by pi this side, we should get just the d by itself, right? We divide by pi, we should get circumference over pi. All right. All right, I'm gonna let y'all work some of the other ones by yourself though. I'm gonna make sure that the other groups know what they're doing. Where no one's 1 to 2. Okay. Are we here? Where Elliot? Elliot's here.
Yeah.
You're here? Okay. You're here? Okay, so are we doing 165, 167, 169? Hopefully we're on that track.
Yeah.
Okay. Do y'all need help on this? This is the next question. Are y'all getting it? Or do you need help or what?
So we're for the C equals pi times the diameter. We would divide both sides by the pi sign.
Yeah, that's it.
Okay.
Yep,
And
yep.
then that would cancel out to be C over pi equals D.
Yeah, that's exactly it. Yep. Everyone's asking me this about that first one. So yeah, y'all are on the same page with everyone else pretty much that I've just talked to.
All right.
All right. So I'm gonna let y'all finish the other two and make sure the other groups know what the heck they're doing. But I'll be back around.
Okay.
All right. See ya.
B times H. Then I divided both sides by H to get 2A divided by H equals B.
That one's a little harder.
You could put, well, first to not make it a fraction, you can put 0.5 instead. I don't know if that helps you.
Well, it's the same. Yeah, it's the same thing. They're not asking us to like necessarily like, I don't know. I guess they are maybe asking us to simplify it a bit, but not really. No, they're not asking us to simplify. They're asking us what it would be if we're solving for B. So first we can put B equals, at least get that out of the way. And then I think base times height, and then we have, it's multiplying. So I think base times height stays the same because that's its own little, like, imagine there's a parentheses around it, I think. I'm not sure. I think I'm right.
Well, it would be two different. Would it not be two different ones? Like I was thinking it could be 1/2 times the height divided by the area.
I think you said that backwards, but yeah, it'd be area over 1/2 height. Is that what you're saying?
Well,
Yeah.
okay. So in these problems,
Okay.
we're looking for B. So I thought the B would be on the other side of the equal sign.
It can be on either side. We just got to get it by itself. And I think what you're saying was like correct, right? You're saying divide by what? Let me speak English for a second. The thing that's there that's not B, right?
Yes.
Okay, so if you do that, that's absolutely true. And this is okay. But there's a little thing. There's just a little thing. And so this gets rid of the half and the H. And so we get, let me rewrite it, B equals A over 1/2 H. So the little thing about this is like we don't really want fractions and fractions. And so if you do this, you will actually probably like, you should really multiply this by 2. And you end up getting like 2A over what, H.
Okay.
And so there's that way, you can go about it that way.
And can I just ask? Okay, never mind. Actually, I just answered my own question in
And
my head.
if there's actually another way to solve this I was going to go over if you want to see it.
Yeah.
Yeah, so if we do areas of half base height. Ooh, I got some echo back in that one. Areas half base height. If you want to get rid of a half is kind of like the same as like what, dividing by 2, right? And so if we just multiply by 2 right off the bat. Ooh, kind of sloppy, but it's there. 2A. And then we have this half and this 2 are going to multiply to be a 1, and we're multiplying by 1. We're not going to see it anymore. So we get half base height, and then the next thing we have to do is divide by height, right? And so if we do that, we get 2 times the area over height. And I'm like, I automatically swap sides and do stuff like that, so maybe I should maybe a little more step by step, but
Oh, okay.
yeah, you're gonna get the same answer either way you solve it. If you multiply by 2 to begin with, or you try to simplify it out in the end. And to be honest, this is the way I would probably go about it in my head. Like,
Yeah, I was doing
like
it like way too simple. Like it was not that simple. Okay. Yeah, because I didn't put the 2 in there or anything.
So, how did you get 2? Or how?
I
Because
think
it's
he divided. I don't know.
because 1/2 is multiplying by 1/2. If we want to
oh,
make this 1, we have to do 2 over 1, right? We had to do the reciprocal.
okay.
And
So
so
we
just
were actually solving
knowing
the
that
problem.
multiplying by 1/2 or is like dividing by 2, right?
I thought it was 0.5. Is it
Yeah,
not?
so 0.5 is a half. Is the same thing as dividing by 2.
Oh, but we're no
Oh,
longer dividing, we're multiplying because
You can think about like multiplying by 1/2 is like dividing by 2, so I have to multiply by 2. Or you can just think about doing the reciprocal of this thing, right? Both of those are correct ways to think about it.
okay.
Yeah. And they're really kind of saying the same thing, right?
Okay, I have a question. Oh, do you have time? Can you answer a question?
Yeah. What'd you got?
For pi d, and which is the first one, that would just be pi divided by d?
You want to get this thing by itself, right?
Oh, that's right. Okay,
So
okay.
what's there that's not that?
The
Pi.
pi.
Just pi. We put this over pi, we put this over pi. Those things simplify, and we got d equals c over pi, right?
Yeah, that's what I put. I was thinking about it for a minute, but I got it.
All right. Now I got to bounce, though, I think. I got like
Okay,
5
cool.
minutes. Yeah. I think y'all got a pretty good grasp on those two, at least, I think.
It's 165, 169, and 167.
Yeah, 167 is the other one that I didn't go over with y'all. I'll go over it when we go back to the big group. Hello. Oh, man. Are we getting these? Hello.
Hello?
Yeah, are you getting this?
Yes, I'm working on 175 right now.
On what, 165? Is that what you said?
75? Is that the ones we're supposed to? Yeah, 175.
Whew. No, I was just working through the first 3.
Oh, I thought it was the first 3 that were assigned on the homework.
So we're going through 165, 167, and 169 is what we're doing right now.
Okay. I was just looking at the like the graded problems, and it shows the third one was 175. I thought that's what you meant.
No, we're doing these 3.
Oh, okay.
All right. Yeah, I got to jump to a different group now. 5, 4, 1, 3. Hello. Hello. Are we getting these?
Yeah, I'm still working on the last problem.
169.
Or was 169 the last problem?
Yeah, that's it.
Oh, okay. Well then, yeah, I think I'm done.
So you got them all, hopefully?
Yes.
All right. Well, we will return in a minute. Where are we at? 2 minutes, actually. All right, see y'all.
I should have known. Like I should have watched the videos. I thought like the videos were just like there if you missed class, but I didn't know you're supposed to watch them until now. It's like,
You got this far?
pi times z.
Oh, I kind of got that too.
Yeah, I got that too. Yeah, like I
Okay.
was because like you got since you can't simplify c over pi, that's what I put my answer. D equals c or pi, or c over pi equals d.
Yeah. Did you get 167, 169?
I didn't get 167 because I have a question for that one. So like since you're trying to get L by itself, really it's basically trying to get something by itself, right? Do you want us to divide W and H together or separately?
Oh, that's a good question. Oh, so we're solving for what? L.
167. Yeah, my bad. I should have been more specific.
That one? Okay, so we're solving for L. What I would do is I would divide them. I would divide them personally both at the same time, right? Divide by WH, divide by WH. And a little bit about that, and I got to go a little fast probably because we're going to run out of time.
So cross them out? Okay.
Those are they make a big fancy one, right? We multiply by one. The bad way to say it is they disappear. They simplify out is right what they really do, right? So we get that. If you divided them separately, what would that look like? You would do V divided by W, and then you would have this thing divided by H, right? And that would be your length. That you get something like this. And a little bit about this is it's fractions and fractions, and we typically like try to steer away from doing.
So basically, you're gonna if I do it separate, it's gonna be a long process and it's gonna be complicated. Whereas
And
if I
you
do
would
it
have
together,
to do you could do some simplifying here, and basically you would get the W on bottom in the end.
Yeah.
You would get the same answer, but with like a lot more work.
yeah, I was confused because I was like, they're together, so I'm not sure if I should do them together or just separately. I don't know.
They are kind of together, but yeah, I would look at them as like do them all at once. I can't see stuff.
All right. I mean, yeah, you're right. Especially since like right next to a letter that's supposed to be by itself.
Yeah, and you do it while in one step. You got it by itself in one step. You know.
Yeah. But thank you, Mr. Seavers.
It's good to think about ways that like maybe I don't know. Yeah. Maybe that approach might work for something else. You never know, man. Doing all right, Gabby?
No.
Math will always stay true, though, huh?
Yeah.
That's one of the things. Like, I mean, I know that, like.
It's just that letters confuse me a lot.
Yes. But for 169, do you want to see? So same thing applies to like 167, just since it's.
Yeah, we're about to
to
be back in that other group.
Oh.
Muted. I'm muted, so you can't hear anything I just said, huh?
Nope.
Great. I just went on a rant. So here's the thing. We're gonna have to do group work, and you're gonna have to work with your group. You're gonna have to find some way to communicate with your group, right? If I'm popping into your group and it's taking like 30 seconds for you to even respond to me, it's not a good sign you're being active, right? I'm popping in. There was most. I think 3 out of the 5 groups were pretty good about it, but there's like 2 groups out there, like, and maybe it's like a little bit about like more about how things look than how things really are. I don't know, because most of those groups had people that don't like have an active camera or don't even have a picture, and it was taking like half a minute to even respond to me saying hi. It's like things need to be a little faster than that. So if it's one of you, take that knowledge for what it's worth. We've got problems to get through, and when stuff like that happens, is like it's going to be more work for your peers because they're going to have to go home and do this homework by themselves. So you're really holding your peers back as much as you're holding anybody else back. So that's basically the rant there. Like, be active in class. Don't be a dingus. These. So I went over these with most of the groups, but if we have pi d, and they're being multiplied, if we want to solve for d, the thing that we have to do is we have to divide by pi. So we're dividing both sides by pi. We get something like what? Circumference over pi. And so I think most of you groups got through at least that one. 167. Volume equals length times width times height. Everything's being multiplied. We're solving for L. And so someone was asking, they knew we were supposed to divide by W and H. They're asking, do we do it all at once? Do we do it one by one? Which was an interesting question. But I think we went over an example. It's better to do it kind of all at once. And so these are the same thing over themselves. They make a big fancy one. They're going to simplify. And I will probably like, this is why we do math in pencil. This is L equals V over WH. And so a lot of times I will just like start probably swapping sides that my variable's on because I really like it to be over here in the end. And so I just like will grab it and put it over here, put that over there. And the last one, 1/2 base height. Do I have it where I already did it? No. So there's a few different ways you can do this. Personally, in the approach that I would do is to get rid of a half. I typically would just like multiply by 2 right off the bat. You could divide by a half, but then you're going to end up with fractions and fractions. And I've said it for a few people. We typically don't want fractions and fractions, right? And so we want to solve, God, what are we solve for in this one? B, we want to divide by H. So divide by H both sides. B is going to be 2A over H. Those things should simplify. That is horribly drawn H. That is 2A over H.
So basically, you multiply both sides by 2 because technically, like when the number's over 1 or something like that, it's like that's the number by itself. Or
if you didn't do it that way, you probably ended up with something like A over 1/2 H. Is that what you're saying? Or am I saying?
No, like the part.
Yeah, that's what I got. Is that not also correct?
This is okay, but we typically try to steer away from fractions and fractions. And if you did that, you could actually get to the other one.
Well, technically, I actually got A over 2H. So that's not correct.
Ooh, yeah, it should not be 2.
Okay.
But why multiply 2 to get rid of the fraction, if you don't mind me asking?
If you multiply by 2 to get rid of the fraction, you will end up with a 2 on the A. Right?
Yeah.
And if you do this, I didn't finish this, but sorry. You should end up with the same thing, right? If you multiply top and bottom by 2 here.
Can you just maybe add why it would be 2 and not any other number?
Yeah, that's what I was asking. Like, why would we use 2 to multiply it to get rid of the half?
Do you get rid of the half?
Yeah.
So if we multiply something by a half, I don't know, in my brain, if I multiply something by a half, I'm halving something.
Yeah.
That's like dividing something by 2.
Oh, yeah.
Another way to look at this is I have 1 over 2 here, if I want to create a 1 by multiplication, I'm doing reciprocals. So 1 over 2, I reciprocate that as 2 over 1.
Which is the whole number, which would be 2 by itself.
Yeah, same thing.
Oh, I see what you mean.
Yep. Okay. So I think it's time to do groups groups part 2. And so hopefully we'll bounce around from group to group. Similar to what I did before. 171. 171, 173, and 175, I believe, are the next 3, right? 171? No. 175, 179. Ooh, where am I at? Oh, we did an extra one, didn't we? Whoops. We weren't supposed to do 167. We did 167. Let's do 175, 179, 183. 175, 189, and where am I at?
So basically, do the questions that are on top of the written homework.
Yeah, that's what we're supposed to be doing. We did an extra one. So 175, I got it printed front and back here, so I got to do it one at a time. So we should be doing 175. The other one we should be doing is 179 and 183. Can I do that? I'm gonna totally do this just for y'all. I think I can do this. Whew, did it perfectly. Look at that. 175. 179 and 183. I'll have to like move it up and down. 175 and 189 are right there on there. And I'm going to set you off to groups in just a second here. As soon as I click on 5 groups. Okay. Let's do 5. Create all groups. And we're off. Can I get like all 3 of them on here? Maybe. I'm running into this thing now. Stupid thing. That probably works, huh?
Do we have to divide again? Or
Okay, so you're solving.
the parentheses with 2.
So this one you're solving for P, right? So this is one of those things where if you're solving, you kind of want to work backwards. So what's the closest thing you see to P is like these things, 1/2 an L. You look further away, what do you see?
What do you mean, a plus?
Yeah, the plus, and there's a what?
A B.
The plus B. So you want to work furthest away first.
I thought we were doing 175.
Oh, shoot, yeah. 175. You want to solve for A.
Do we do the parentheses? Or we don't?
Which parentheses?
To get rid of the fraction? Or we leave it there?
So you want to solve for A.
Do we move over the 54t first?
Yeah, so you want to look at A. So A is being attached by multiplication to these 2 things. but we look furthest away first. And so the furthest thing away on this side is this 54t. And so I think you said it right, subtract 54t. The operation between these things is addition, subtraction. Squared A subtract 54t. Back to the other side.
All right. And then would we divide both sides by t squared? Next?
Yeah. So you can divide by t squared. And so this looks like a equals that half.
Mhm. And then we'll multiply both sides by 2.
Okay.
And we multiply 2 so we can cancel out the half.
You want to multiply both sides by 2. And so, I'm going to just kind of do it, but it's like, you can think of it as like 2 over 1 if you want to. I'm probably not going to put the 1 there. But what is that 2 getting multiplied to? Because you really should put something there. It's not quite complete. Parentheses around this thing. So you want to make sure that 2 gets distributed to everything over there. And if you could put this over 1, right? But that 1 in the denominator, it's not really doing anything. You're just doing 1 times t squared. And so I'm just going to extend that if that's okay. Do you understand like why I'm doing that, hopefully?
Mm-hmm.
The 2 goes on top typically. If you multiply by whole numbers, right? They're usually over 1. They're going to go to the top typically. In this, I guess if you want to, you could distribute that if you wanted to. Being honest, if you got that far, I think that's pretty good.
Okay.
Distributing it's not really making it a whole lot prettier on that one, you know?
Yeah.
Yeah. All right. All right, I'm going to let you get started on those other 2. Do y'all need these? I need to copy them down right quick.
I have a photo of it.
Okay. Are you copying them, Leslie?
I was, yes.
Okay. I'll wait for you then. Let me know.
Okay, I got it. Thank you.
All right, cool. See y'all. Y'all are good. She's in that room. Let's go to 4.
So, in my opinion, I think it would just like the answer should just be y equals 15 over 8x. But that's just me. That's what I assume.
Yeah, I think it'd probably be like y equals 15 over 8x.
Yeah.
That's it.
No, but 179 I still did not get like because it says let me see.
Wait, what are you doing with the 8x?
For 183.
Uh-huh.
Yeah, so basically since it says solve for the formula 8x plus y equals 15, and you're trying to get y by itself, right? So what I did in my best of knowledge on this is I divided 8x by itself because it's a fact, it's being multiplied basically, right? So
Wait.
What's
the operation between those things?
Multiplication.
We're solving for y, right?
Yeah, y.
We look further out. What's the operation between these things?
Addition.
Uh-huh.
Oh, so you gotta subtract 8x by itself.
Yep.
Oh, so the answer should be y equals 15 minus 8x, no?
Yep, that's it.
My bad.
What else? What other one are you asking?
179. We kind of skipped that one because it was confusing.
179 half PL for P. Okay, so we start here. This is what, multiplication. So like when you're solving these things, you're kind of like working backwards, right?
Yeah.
Okay, so we're working backwards. This is like multiplication. And I mean like with respect to like PIMDAS, right? And so it's like This is multiplication. We look further out. We always like kind of go furthest out. So this is kind of the first thing we want to tackle. So what's the operation here?
Addition.
Addition, and you're adding b. So if you want to get rid of add b, we have to
Subtract b.
subtract b. So subtract b from both sides.
And do to the other
A
side.
minus b equals 1 half p. That guy P.
Where'd that R come from?
What? Where?
The right next to the negative or minus
Sorry.
b. Oh,
That's a
my
B
bad.
that didn't get connected all the way. It was like,
So,
okay.
so it's A minus B equals half PL.
Yep.
Right, PL, P1. Yeah, PL.
Trying to do P. So how do we get that P?
So P, I guess you would divide it as being multiplied.
Is that whenever you multiply by 2? Because they got that.
We can multiply both sides by 2.
I
want to multiply this side by 2.
Oh, because of the half, right.
This side by 2. Yeah, I'm going to do this. Okay, so if I do it on this side, I'm going to get P. Sorry, I went from like print to cursive for some reason in my L, but it's there.
All right, so on the other side would be 2A minus B, right?
Oh, man. So that's what I'm trying to get. What do you not want to do here? So this is this entire side. We multiplied this entire side by 2. Guess what we also got to do over here?
Multiply.
Yeah, but what do we have to multiply?
A and B.
A and B. So what
So
we
just
should
the
really
B.
do, yeah, you should really put some parentheses around this thing, right?
It'll be 2A minus 2B.
Yeah, so be careful. I was trying to slip you up by not putting parentheses around there, so I kind of did that intentionally. So
Dang, so parentheses do help, huh?
yeah, trying to make sure you catch that. Right? Sometimes it's harder to catch things when people lead you, though, too. So we're solving for what? P?
Yeah.
Last thing we need to do is do what?
Put P by itself now.
Yeah, so how do we do that?
Divide L.
I'm just going to be really lazy and do this. P over L, right? 2A minus 2B over L is equal to P, right? Is what that says.
Yeah, and that's your answer since you can't really simplify it or make it more shorter.
That's it.
But,
all right, I'm
so
going to
that's
let
like
you
a
work.
two-step solution.
I'm going to let you work on that other one by yourselves and jump to another group here. I'm in 4. I did 5 already. She's in 3. Let's go to 2.
Those that we watch don't help. Oh wow, the screen finally came on.
Yeah.
I would say if the videos don't help, sometimes I look at different ones. Sorry again. I look at other videos and see maybe there's a step that I missed, or maybe there's something that can be done differently. But usually, what I like to do is that I do 2 things: flip the equation and isolate the variables. That usually sets up the formula that we're trying to do, which of course is solve for the formula before you can solve for the variables, if that makes sense to you all.
Yeah. Okay.
Okay. Are we all ready for 179?
Yes.
Okay. Well, listen, I don't want to hog everybody's time or hog all the audio. If one of you would like to do 179, that'd be cool. If not, I can go ahead and do it.
So I'm sorry, I'm actually like writing it as I go right now. So let me just read it out loud for you guys. So A equals 1/2 times PL plus B, and we're solving for P.
Correct.
Mm-hmm. So we're trying to solve for, we're solving for, okay, yes, we're trying to solve for P.
What'd y'all get for 175? Did y'all do that one already?
Yes, sir.
Yeah.
We got A equals 2H minus 108T over T squared.
Okay, yeah, that's it. Y'all understanding like how he's getting at?
Yeah.
Yeah.
We had like how
Yeah,
to
we
set
just
it
went
up,
through it.
formula.
Yeah.
Okay.
It's usually the formula. It gets a little tricky, but Zahara, for 179, yes, for that one, We don't get so
Yeah.
far. If I may.
There's a few different ways. I mean, these it's not really like certain. Like there's a few different ways you can solve it, and it's one's not really more difficult than the other. I don't know. It's not very clear where the stopping point is on these so much, maybe. But if we have something like A equals 1/2 PL plus B, and we're solving for what? P.
Yeah.
So it's kind of like we're working things backwards from like our sort of PIMDAS that we learned, right? If we're solving for P, like the first thing I see here that's attached to it is like what, 1/2 an L? And they're being attached through multiplication. And so we kind of like want to look furthest out. And so the thing that I see that's furthest is what?
B.
B.
Yeah, it's plus this B. And what's the operation?
Subtract.
Yeah, it's addition. So if we want to get rid of B, we have to subtract B. So if we're subtracting B from both sides, this side's going to give me what? A minus B. This is going to give me what? 1/2 PL.
Yeah, that's what I got.
And now here comes that thing with like kind of like we had in that previous problem.
And reciprocal.
Yeah, there's a few ways to do it. But if I have a half and I really want to get rid of it, I can multiply by 2. And this came up in the previous problem, but like I want to multiply this side by 2. And let me go ahead and do this. This 1/2 and this 2 will simplify out. This side's going to be PL, right? I want you to like take a good look at this side. Ooh, maybe zoom out a little bit. That might be a little better. And what should I really do to this side? Like what gets multiplied by 2?
Well, I multiplied both of them by 2.
They both should be. And so I really should have some like parentheses around this thing, right? And I'm like hoping like you take a minute and pause and like take this into perspective. Like if I have multiple terms over here, all these terms I got multiplied by 2. I'm multiplying the entire side. So always like I know like mathematicians like put parentheses around everything, and it's not always the best thing, but for here it really does work. We really do got to distribute it, right?
Right.
Yeah. And I think we did that on the previous problem too. There's a similar sort of issue that comes up. And then the last thing we have PL equals this thing. We want to solve for P. The last thing that's attached to P is that
L.
The L. If we want to get rid of the L, how do we get rid of it?
Divide it.
We gotta divide by L. Divide this by L. And I'm gonna be kind of lazy. I don't feel like rewriting this thing. But that should be your solution, right? We got P by itself. We get 2A minus 2B divided by L.
I got
All right, I'm gonna give y'all some minute to work on the last one, but I gotta bounce to somewhere else, I think. Wish you luck.
Thank you.
Thank you.
All right.
I don't know if I have it right. I'm probably.
What did you? I got like minus y equals x or something like that. I don't know. I probably
Yeah, for that one I have minus y equals minus 4 minus x.
Oh, okay.
Because the x is positive, so you have to subtract the x from both sides. But I don't know if minus y is the same as solving for y. I'm probably gonna wait for the teachers on that one.
Which one? Where?
187. I'm a little ahead of what Professor Sievers told us to do.
I'm not talking about that yet.
Hello?
So on 183,
Well, just reverse it.
I'm not talking about that yet.
Oh, okay.
I'm not talking about it. We're talking about these three right now. It's all right. I'm gonna some now. I have 187. I don't know why I tore that. I'm gonna still need it for this anyway. Get a little too anxious, just ripping stuff apart. For y? Oh, you gotta move the x over, and then you gotta like multiply by negative, right? Something like that.
Could you put a -1 in front of the y?
You can put a -1 in front of it if it makes you feel better. But yeah, that's a good way to think about it. But yeah, you do have to account for that negative in front of there. Right. All right. Y'all get the other three?
Yes.
Yes.
Okay. Oh, put it off somewhere. No. I think every group's been to. God, I hope so. How we doing? Are we getting through these?
Yeah, I think we got through them.
Okay. We'll be going through them in a minute. We ain't got too much longer. Okay. We're on 2, 3. Down somewhere. Yep.
Come on.
Okay, speak view. Where am I coming up? Come on, pin me. Okay. Yeah, this is blurry. Let's kind of fix this up a little bit. There we go. Maybe not. I don't know what I did with that one. I lost a little sheet of paper. So let's go. 175 is the first one we were doing. $175 looks like H equals what? 54t plus what? 1/2 AT squared. And the thing we want to solve for is A. And so, like I've said this in the groups, but like we kind of want to do these things backwards of like what we're doing when we're doing PEMDAS, right? We look at this thing, we see what's closest to it, we see like this is multiplication. We look furthest out first, and so this looks like what? Plus 54t. And so the first thing we're going to do is get rid of the thing that's furthest out, which is this thing. It is addition, subtraction is the operation. So we want to subtract 54t. So the next thing should be what? H minus 54t is 1/2 what? AT squared. And now this comes to that thing, we have a half in there. We don't really want to end up with fractions of fractions. And so I think the easiest sort of thing to do is multiply this by 2. And I'm really sort of glad they did this here, because if I did this here, I'm hoping like after I went from group to group, at least 2 of those people can tell me I should put some parentheses around this thing, because when I do this, I want to multiply that entire side. So this issue comes up, and it comes up again next problem. But hopefully you did some distribution. So like, or at least you put parentheses around things. I think I left it factored out in one of them. But this is giving me AT squared. And now if I want to solve for A, the last thing I need to do is divide by a t squared. So 2h minus like what, 108t over a t squared.
Yeah, Mr. Supers?
Yeah.
What confused most of my group is what to do with the AT squared. I mean, the equation that you have a result, and that's what I got, of course, but could you explain how the t goes from on the other side of the equal sign and the t squared goes underneath the 2h minus 108t, please?
Okay, yeah. So I'm going to pick it up, 2h minus 108, like right here, right?
Right.
And so I want to divide both of these by a t squared. So I'm dividing this by t squared and dividing everything by a t squared.
Awesome.
And so if I do t squared over t squared, that's my big fancy 1. This is the same thing over itself. And so that's how I solve for A.
Excellent. Thank you so much.
Yeah.
So, like, there's an exponent in there. You don't even worry about like trying to.
As long as, yeah, so the exponent in there, as long as it's the same exponent, it's the same term, right?
Yeah.
Okay. And so as long as it's the same term and it's the same term over itself, we still get that fancy 1. So we will do exponent like rules like later, and there is a way to simplify exponents if they're not the same. But as long as they're the same, it's the same term.
All right.
And we still have that property of oneness, right? That everything is all in the 1. I don't know. Did everyone get that one? Are we together on that one?
Yeah.
Okay. Okay, so let's do, what was the next one? 175? 179 was the next one. So this one looks kind of similar when we solve it. So I think these two might be some of the more complicated ones in this homework. 1.5 PL plus B. So same thing, we're solving for something that's kind of in the middle. We look furthest out. The furthest out I see is this thing, this plus B. So I'm going to subtract B from both sides. So if I do that, this is what A minus B. This is a half PL. I could put my steps in black, maybe. That'd be a little bit better, huh? Boom. Two-tone. Okay. So we get A minus B on the left. We get no more B's on the right. We want to get rid of that half. And so this is that same sort of thing that we did in the previous thing, right? Multiply by 2. And if I multiply by 2, the same issue comes up. You better multiply that 2 by that to that B as much as you multiply it to the A, right?
Distribute.
Distribute, distribute, distribute. And this is PL. And now we want to solve for what? P, I believe? The
Yeah,
only
for your
thing left,
L.
divide by L. So P, I'm going to do this, and I'm going to swap sides and do a bunch of stuff probably all at once. 2A minus 2B over L.
So y'all both would like to see the variable on the left side. Is that like a rule of thumb? I know y'all both say you just prefer it, but I noticed that it's common.
Yeah, it's common because it just tells you right off the bat, this is the thing that I'm talking about, right?
Oh, okay.
And so when we start doing functions, I think it'll be like a little more obvious why we do things that way. But it's just like we want to be able to solve for this single variable. And it's just like, well, what do we solve for? P. It tells you right there. And then, okay, this is the formula we have to plug things in to solve for it. It is like a little prettier in my mind. I don't know if it's, I can't honestly tell you if it's like my own personal bias or if it's something that is actually mathematically sound, to be honest.
Okay.
Yeah, I feel like it's one of those things that's probably just more of a bias than anything, because technically, if you flip this, it's equally as correct, right?
Yes.
But yeah, I don't. It just looks prettier to me. That's all. That's all. I don't know. The last one. Did we all get that one? Hopefully. Any questions? Going once, going twice. Sold for
Yeah,
180. Oh, for what? 179 or 183?
187.
Oh no, that's too far. We're not on there yet. 183 is the next one. I don't even know what number that is. Okay, 183 is 8x plus y equals 15. If we're going to solve for y, what am I doing?
Subtracting 8x.
Subtract 8x. Okay, so this side is just y now. This side, you probably wrote 15 minus 8x. I'm going to be complicated, and I'm going to do that.
Could you write them either way as for y?
You can absolutely write it either way. This is the same thing, right?
Awesome.
How is it the same?
So we're just reorganizing things here, right? If this is a negative 8x plus 15, this is still at positive 15, and this is still a negative 8x, right? This is, you could look at this as like plus a negative if you want, right? That's why I look like when I see subtraction, I actually see plus negatives in my mind. Because I know like addition is a lot prettier because it's commutative. We can just sort of flip things around as long as we keep the negatives on them.
But doesn't it matter? Doesn't it matter which order you put it in? Because if you subtract
it does if you're subtracting. But if I look at everything as addition, then it doesn't matter what order I put things in. Because 2, right? 2 plus a negative 3 is the same thing as a negative 3 plus 2, right?
Okay.
And so this is what I do in my mind. I actually don't subtract things in my mind. I just do plus a negative. And then I subtract things to actually crunch the number. But in my mind, this is the way I resort things. I look at them as plus and negative. And so instead of like 2 minus 3, I will look at it as like 2 plus and minus 3. And so in my mind, I can automatically sort of flip these things. But I'm also saying in my mind, and I've been doing math. Oh, God. Shit, now I got to think. I graduated in 2005 from high school, so I don't know. That was 15 years ago. God, 20 years at least of doing probably this math. So I know like I do things quick. Like don't like try to, to like think that like you're just gonna like, I don't know. I don't think I'm good at math, to be honest. Like I'm not that
You're doing
great.
good so far.
Yeah, but like you never realize that you're doing good, right? If you're progressing yourself in math, you should always do something that challenges you, and it shouldn't make you feel good. In some essence, right? It shouldn't be reassuring. It should challenge you, and it should make you think, right? So, that's one of those things you have to practice, is what I'm trying to get at, right? It's not something that just came overnight. And so that's the last one, 183. I think we need to bounce back into groups, and we need to do like the next 3, and then we'll come back together and do the last one. So we need to do 187, 189, 193. 187. I will find those. I'm going to put you on groups, so that's.
And it's past 10:20, so if
Is it?
yeah.
Oh man.
I'll post all the solutions too if anyone has to leave.
Okay, thank you. Yeah, because I have to leave.
Same here.
So if you have to leave, it might be beneficial. I'll just go over the last 4. So we're doing 187. I had it. Here's 187, 189, and okay. 187. And I think some people got started on this or had some questions. The first thing that you do, and I think I'll just give this away because I think most people have this, is we look at that y, we're trying to solve for y. The furthest thing out is an x. And so this is addition, subtraction between these things. So I think most of you were on the same page with the subtract x. So negative y equals, and I'm going to write these things in the same order I did the previous thing. So if I want, maybe I'll just go put it, I could put a 1 on there. It's a negative 1x, right? I can think of this as having a 1. I guess I'll do that so we keep these things kind of straight. And I still have a -4 here that I have to count for. And if I wanted to put a 1 here, I could put a 1 here. What's the next thing I should do?
Divide both sides by the negative.
By what?
Divide both sides by the negative one sign.
Yeah, so it's like, if you want to think about it as dividing, dividing's good. If you want to think about it as multiplying, multiplying's good. Either way, we got to multiply this side by a -1. And we got to multiply, what are we multiplying by a -1? So we're doing that side. And what should I really put around this thing?
Parentheses.
Yeah, I should really put some parentheses around here because I got to multiply -1 and I got to do it there as well as here, right? And so if I multiply -y by -1, that gives me positive y. This thing is going to become what? Positive x. This thing is going to become a
Positive 4.
positive 4.
So
like what? X plus 4?
So we multiply 1 because of x, and x is multiplication, or something like that.
Are you talking about here? We're multiplying a -1 to make this thing positive, right?
Oh, so the answer, so that way it can be like by itself, get y by itself, but that's positive whole number.
Yes, because we were almost there, but it had a negative on it, right?
So basically, you can't have the y or variable by itself if it's a negative. That always has to be positive.
Yes, it has to be positive 1. Yep, that's good. Good
So
observation.
that's a multiplier. So I see what you mean. I got lost for a second. All right, but
So you can divide by a negative if you want to think about negative, but like at some point, like I just think personally the way I view like multiplying by negatives is like swap the sign of everything there, right? It's like this y was a negative, it's going to become positive. This thing was a negative, oh, it's got to become positive. This guy was negative, oh, it's also got to become positive. So that's another way you can think of it. It's just like swap every sign. Any more questions about this one? Okay. That's the gavel then. Okay, so that was 187. The next one we need to do is what, 189? 4x plus 3y. And so the first thing we want to move is what?
3y. I'm sorry, you want to move the 4x on the other side.
Move the 4x to the other side. How do we do that? We subtract the 4x. So we're going to subtract the 4x. It's going to become a -4x. And I still need what there?
7.
Plus
7.
Plus 7. Yeah, that's it.
Oh,
so I was still awake.
I thought I had to put it like next to the 7, but I guess I was wrong.
You can do 7 minus 4x. That is correct. I am just trying to lead y'all in a certain direction here, to be honest.
So it doesn't matter which way you put it?
It really doesn't, but I'm trying to lead you a certain way for a certain reason, right?
Yeah, okay.
Yeah.
Make it
It's
easy on
going
us.
somewhere. I'm not just doing it for shits and giggles, right?
Yeah.
There is something to it. So this is 3y equals a negative 4x plus 7. If I want to get that y by itself, how do I do that?
Divide 3 by itself.
Divide 3y by, I think you said it, right? By 3.
Yeah.
If I do that by 3, what over here am I dividing by 3?
The negative 4x plus 7.
This entire thing is divided by 3. So we might need to talk a little bit about this. When we were doing addition of fractions, right? We got a common denominator, and then we like put both of those things over a common denominator. This is kind of like going the other way. And so I have a negative 4x. And if I wanted to, I could do what? You could probably give me this, and I would be happy with this section. But I'm trying to lead you somewhere on this one, to be honest. I could put this over what number? 3.
2, 3.
3, and I can also put this one over 3. And so, like, this is like if I went backwards, it's like I'm combining fractions with a common denominator. You can also split fractions with a common denominator, right? And they
So
both.
in this case, instead of 4x plus 7 over 3, you can just separate it into like 2 fractions with the same number in the bottom 3.
Yes, it's
All
working backwards from what we did when we did the common denominators adding fractions, right? It's just backwards from that thing. It's like we can split them, we can put them together over a common denominator. But it has to be the same denominator when we add and subtract. And I'm trying to go somewhere with this. If I want to put the x on top, I can put the x on top. If I don't, I can put it like this, and you'll probably already know. That hopefully that form looks a little familiar. The mx plus b, it's a linear form. Standard linear form, not standard. Slope-intercept form is what I'm trying to dance towards. And so that was what, 189. 193 is the next one. 3x minus 2y equals what, 18? We're solving this for y. So if we're solving for y, what's the first thing I'm moving?
X. So minus 3. Oh, no, never mind.
So this negative still stays here. Like that's something some people slip up on. Keep that negative on that coefficient. And we're going to do what? Subtract x. Subtract 3x. If we do that, we get minus 3x plus 18. And now we want to get that y by itself.
Divide 2 by itself. Negative 2.
Divide by a negative 2. Divide by a negative 2.
And then it'll be 3 over 2, negative 3x over 2.
Over what, Sergio?
Sergio. Oh, no. Negative 3x over negative 2.
Yeah, got to be negative.
And then I guess you put plus. I mean, I have a question. Can't you technically simplify 18, make that into 9? So instead of like 18 over 2, put like 9 over 2, negative 2.
Okay, so let's do that. Okay, so let's clean this up a little bit first. So if we have a negative over a negative, we actually
That's
don't
positive.
really need, we don't need a negative. It's really a positive, right? And this thing is 18 divided
Over
by
negative
minus 2. This is really what, minus 9?
Yeah.
And so I'm probably not going to put plus negative, so I'll clean that up a little bit too, maybe minus 9, right?
How can you decide that you're just gonna make the addition to a negative number into subtracting?
Because if we add a negative number, it's the same thing as subtracting, right?
Okay.
If I'm doing like what?
Oh, okay, I see.
5 minus 4, right? Would be the same thing as like what? 5 plus negative 4. I'm going 5 in the positive and I'm going 4 in the negative, right?
Okay, makes sense. Thank you.
Yeah. It's kind of the thing that I look at, like, it's the same as if you're like multiplying, right? Positive and negative is going to make a negative overall. The thing you really got to look out for is those double negatives are going to make positives when you do those sort of things. So if you subtract a negative, then you do have to flip it to like addition, I guess is one of the things. So this is it. Questions about this? It's the same sort of progress, right? If we're solving for y, that first thing that's sticking out is the x term. You move the x term, and then we got something like, what, 2y? We can divide by that 2.
So basically, what we have to do is just, if there's something that you want to get by itself, do the opposite. So if it's like multiplication, do division. If it's subtraction, do addition, vice versa.
Yeah.
And then apply it to the other side.
Yeah, and you kind of start from the furthest most out from the variable, right? And you kind of work your way back. And it's kind of like you're working, like I kind of said, it's like almost reverse PIMDAs, right? Because we're doing subtraction before we do division. And so you should be doing things kind of in a reverse sort of PIMDAS way, typically.
Yeah, so basically, like, instead of doing multiplication first, you want to subtract first.
Yeah, and I don't want to say that. I mean, there might be a problem that like breaks that rule. So I don't want to make that like hard set.
Yeah.
But like in general, it's sort of like you're working backwards. So typically you're going to be doing things in a reverse order, PIMDAS order.
Can we just like leave the answer to like fractions, or like what?
What do you mean, like as fractions? Like
Because
just
I noticed that below you did plus times -9.
Where were you talking about? Times -9?
Because I was at like y equals -3x divided by 2 plus 18 over -2. Can we just leave it to that, or do we have to do that extra work right there that you did at the bottom?
So this is 18 divided by 2. If it's whole numbers that actually like compute to a whole number, you should really give me the whole number.
All right.
You should really simplify that. Yeah.
All right.
And what have we got? One more. 195. So a triangular flag has an area of 0.7 square feet and height of 1.5 foot. What is its base? So what formula am I going to use here, I guess?
Area of a triangle.
Area of a triangle. We're talking about a triangular flag. It's giving us area. Area is what? 1/2 base times height.
Yep.
Oh, I think the red pen is running out. Half base height. Let's go to the second red pen. Okay. And so the area is 0.75. And so we can fill that into one of the variables. And it's got a height of 1.5 feet. We can fill that into the other one, and they want to know what the base is. So if you wanted to do things symbolically, which most of you probably don't, you could solve this for B. I think we might have done that earlier.
Yeah, we did.
Base equals what? 2a over h?
Yeah, you have to multiply both sides by 2.
Yeah, so we did that earlier. If you want to use that, you can use that. If you want to use this, you can use this. But they give us an area and they give us a height, right? So if I wanted to fill it into this one, it would look like what? 0.75 equals 1/2. I want to know the base, the height is 1.5. Ooh, I'm like crunching everything in there, I think. That will solve it for you. But I think they're trying to get around to this point. And the point was, like, we solve these things, and we solve these things symbolically, because if we do that and we want to know what B is, now they're asking us what B is. It's 2 times our area, which is what, 0.75, and we have to divide this by a height, which is what, 1.5. This is probably a little bit easier and a little more straightforward just to plug things in and solve, because now we just have some order of operations to deal with, right? And what is 2.22? If we got 3/4 and we do that twice, we get 6/4. 6/4 is how much?
1.5.
Yeah, I think we get 1.5 over 1.5. So B is
Base is
1.
1.
Yeah. And so if B is 1, you probably want to give them some like dimensions there, and they're talking about feet, right? So again, like our base is going to be in feet, our height will be in feet. And you can bring it down a little bit. Our base will be in feet, our height will be in feet, our area will be in
Square feet.
square feet. Yeah. Did you ever see witches?
Yeah.
They had square feet, didn't they?
Real,
Remember that
real
movie?
quick, just in case we don't put indentation equals 1 feet, will we get points taken off for that? If we just put B equals 1?
Ah, man. It depends if it's a word problem, and they're asking. I mean, like you're doing like most of the work correct, right?
Right.
It's like a half point or something, It's like not a whole point.
It's not going to kill the whole problem. All right.
Yeah, you'll get pretty good credit, but like you should really put your units, like in a word problem
Yeah,
in
you're
general.
right.
In a word problem in general, like you should kind of answer it in the same English that they're asking it, right?
Mhm.
And I'll make a
Makes it
lot of
easier to
jokes
read.
because a lot of people give me like a math answer, and it's like I really need some English here. Like if I were your boss and you told me this, like, God, I would be so mad, right?
Yeah, it helps keep it organized.
Yeah. Someone chatting? Anybody need? Oh, she said bye. Okay. That's the final problem, ain't it? Do y'all need anything else? Do we need anything else? Any other
I'm
questions?
all good. Thank you, sir.
All right, y'all take care. Get
I
the
have a
homework
question.
done. The lecture should be up. Yeah, what's up?
Okay, so using our calculators, you're encouraging us to, once we break down the problem into basic math, that we can just start working on our calculators. That's like encouraged, right? Because we're gonna be able to use them on our tests also.
Phew.
Because I'm just trying to figure when to use calculator, when not to. So from what I understand, we kind of break it down. Once we can get something that we can actually put into our calculator, then we use it, right?
Yeah, I mean, most of this stuff I feel like you shouldn't be using a calculator on. If
Oh,
I'm being
no,
honest.
I mean when it's numbers that are beyond simply, doing.
Yeah, I mean, most of these are like what, quarters? We can do quarters
Correct.
pretty good in our brain. Yeah, and so I think those aren't too bad to do in your brain. If it was like anything else, like 0.813 or something crazy, I would be jumping to a calculator quick, and so I wouldn't expect anything different from you.
Okay, and this includes tests also, that it's there as part of our resources for the test, a physical
Yeah. Typically,
calculator.
it's not a big deal. It's just like when students are really lazy and they're like trying to do like this in a calculator. It's like, dude, it's taking you longer to type that stuff in a calculator than it is
Mhm.
just like doing your head, or should be, right?
Yeah.
Yeah. It's just like we're not trying to promote you to be super lazy, but like if it's decimals and it's crazy, I'm not expecting you to do that by hand. No.
Yeah, because I was just good, because you were talking about getting a scientific calculator. I got one, so just trying to be like, when do we use it? When do we not use it? I
Yeah.
was just kind of guessing when it was appropriate.
Yeah, I
But I
mean,
guess there's nothing like an actual rule though. As long as it's a regular calculator, then it's
yeah, I mean,
fine.
it's fine. Yeah.
Okay.
Yeah.
Okay, so and then also can we use so whenever I'm doing a formula, I'm trying to use the paper more of the room of the paper. Instead of going straight down, which only uses like half the page, I use these big slashes to separate the different parts of the equation I'm working on. So would you think that would confuse you guys when you're grading it or something?
I would have to see what you're talking about there. Like, I'm not sure.
I don't know if I can draw on here. Here, let me show you one here.
You can maybe put
I
it up
don't know
to
if
the
you can show
webcam,
this.
like
You can see with the webcam.
slash. Yeah.
Okay, so let me try to light it here better.
That seems valid.
Let me
Seems
see which one.
okay.
Okay, here it is at the bottom. You see that big slash right there?
Yeah.
Those big slashes, that's what I use to try to separate it. So I can do my work across the paper and actually use more of the paper. You see?
Yeah, I mean, yeah.
I don't know how easy it is to see that.
I just don't know, like, if you just keep doing that, like, if that might be confusing when we do division.
Mm-hmm.
Yeah, I don't want to, like.
Yeah, I mean, I use overly exaggerated slashes. It's different
Yeah,
from
I
a
mean, it
regular
looks
slash.
pretty good for the most part from what I'm seeing. I think you're all right. I would just, like, use caution is what I'm trying to say. Like, use caution when we get to dividing stuff that I can see that it is separate and stuff like that.
Yeah, I'm trying to think of some kind of symbol I could use to separate it.
Parentheses.
No,
don't do parentheses.
I noticed something. Oh, parentheses.
No,
okay.
no, don't do parentheses.
Oh. Okay. Well, in any case, like 10 by 10 is an identity, right? So what about variables like x equals